Okay, so after understanding the sequence of the activity, these are some of the basic guidelines for scheduling. Okay, so first, of course, the activities is very important, and then you need to determine the relationship between the activities that is there. So yeah, we'll put it at step 3, but in fact, step 1, while you are at it, you should be looking at it already. And step 3 is basically just to re-look at that particular relationship. Okay, and now once we've got that relationship ready, the first part of the Gantt chart is ready. Then the second part is the duration, the activities duration. There's 2 things that I want to emphasize here now. Is first thing is the first way of coming up with the duration of the activity is not by experiences, it's not by pulling things out from the air and say, look, this is going to take 10 days, roughly 10 days. These are going to take 12 days. These are going to take 14 days. No such thing. Okay, so it has to be a very systematic way. And a lot of these are being overlooked by our engineers in the field because they base it on their they base it on their experience. They think it's simple, you see. So actually, in fact, you must actually have a production rate. All particular resources have a production rate. This is the first method, the first basic method that you do. You must have production rate. So machinery have their own production rate. Labor have their own production rate. And delivery have their own production rate. Okay. So if a factory can come up with 100 pipe, okay, per day, you're ordering 1,000. So basically it means that 10 days to produce all this pipe. Correct or not? And then from there, the delivery to the site, is it by boat, by ship, and all that, you need to factor in. So transportation wise, you already need to have production rate. And then after that, you also need to have production rate for machineries. Machineries, labor, and machinery labors, they all have production rate. How much can a bricklayer lay in a day? How much concrete can the concreter pour in a day? How many batch of concrete can be produced in a day? You see, so by this particular plant that you have, whether it's an external plant or internal plant, how many load of soil can it be? Can your excavator upload in a day? So all these are actually found in the understanding of the resources that you have. So with the resources data sheet, the one that is available, it should be attached with what we call a production rate for that particular resources. So some, yes, it's a very bookish kind of resources, meaning that you get it from catalogs, but you need to factor it up or factor it down. Some is actually by you potentially working with that subcontractor or your team of people, you know how much they can do in a day, you see. So you can actually always factor it down 30% or up, by 10%. You can play around with the production rate. It is not a fixed one. So if the weather is good, maybe they can do more. If the weather is bad, they can do less. The things like that, you can actually factor it. And then sometimes you may have very newbies kind of concreter, very newbies carpenter, and very newbies bar benders. Then you may need to factor it down, meaning that you need to actually water it down with 30% or 20%. They may be late because they're not so good at it, So production rate is the first thing. So production rate is actually how much can the resources do in a day. So then if you divide it, that production rate is actually equal to quantity divided by time. Okay, so if you take time and exchange it with production rate, that means is quantity divided by production rate, and you will get your time. Okay, so that is the amount of time. If I say that I can, my power machine can do 10 pounds a day with this particular soil condition, okay, all factor in already, that's about 10 pounds a day. So if I have about 1,000 pounds to do, that means I need 100 days. Do you know the calculation? Can you see the calculation? Are you clear about the calculation? Okay, so basically 10 pounds per day, quantity is 10,000, 1,000. So 1,000 divided by 10 pounds a day, you get your time. Okay, so this is what we call production rate. So production rate is basically rate is equal to quantity divided by time. Okay, so this is a very simple but very important formula that you must remember. So once this is done, you could actually produce, your activity durations will be all day already. So if you put in the activity duration and straight away you want to draw your time chart, is fine. Okay, but there's another thing that I always emphasize for our people to do, our engineers to do, is think about risk assessment. Assess the list of activity depending on the risk. Think about whether some of these activities may be affected by certain things, some certain unexpected things. So this is a risk assessment that will delay the project. So if you know that the risk assessment is there, the risk production is there, then you can actually adjust your production rate, and that will give you an even better and more solid kind of schedule. Okay, so it will be really, really solid. So what happens is you take your risk. Every activity may have potential events that will cause delay. You think about that, and if it's a very high risk kind of thing, then you may need to factor your production rate up or down usually. Okay, if there is if the risks are very low, then you may want to stick to the original production rate and just decrease it a little bit maybe, or you may not see the reason for it, and after you do your risk assessment. So risk assessment is very important. The technique of risk assessments, we will explain that in week 11 or week 10. More likely week 10 or so we will do that. Okay, so risk assessments is something that if you can input that into your duration calculation, it will be highly favorable. That means your production rate can either be maintained or reduced, or in some cases you may want to up it a little bit. If you need to up it a little bit, then you need to get more resources. So again, you see, the idea of project management is about balancing between things, balancing between resources, between potential bad events, about production rate, your resources production rate, with time, with money, with quality. So all these are a balancing act that you actually do for the project as a project manager. Okay, so with this, you basically can draw your schedule now, isn't it? You know your time, you know your logical relationship. So if let's say there are some that you just don't get that production rate, you cannot get that production rate, so you may want to bring in another team of people, and this is whereby you need to redetermine the logical relationship. You see, in the first place, step 1, we've already determined that logical relationship. That is a logical relationship. Then after that, you determine the duration and the production rate and the risk assessments, and from there you will realize that some of this logical relationship may be able to be adjusted by having parallel activities, by putting in more resources, by improving the production rate, and you may want to redetermine that logical relationship. And then also, before you draw, you think about potential constraints. Like example, these are all external constraints if possible. Okay, when we talk about internal constraints, they are already appearing here in the duration calculation. Okay, internal constraints. Okay, it's internal constraints. So this external constraints is whereby you think, some activities must finish within this month. Some activities there's opening of another project next month. So I must finish certain activities here so that I can shift some of my resources to the other project. So those are external constraints that you can think of. Like the example that I said, Pusat Jantung is another project. It's nothing to do with mine, you see, of my project, but my water, because of their opening ceremony, they need water. So if they are going to open in October, my water pipeline has to be finished by October, at least that stretch for the water to go in and serve the that particular area, you see. So those are external constraints. Those are environment of the project that will actually affect the schedule of the project. Then you produce your schedule, and the final step is monitoring and controlling. Okay.